All right, welcome to chapter 12 of the cybersecurity class and also the CompTIA Security Plus. So in this chapter, we're going to look at secure applications, which is actually a very, very important topic. I hope that you can comprehend it both for your exam and then obviously for practice. Part of the issue is I always say nowadays everybody says they're a software developer or coder, and the question is, are they really trained to understand the secured way to code? And it's even more important now that you can even have a generative AI write the codes for you, or you should be able to still translate or look at it and interpret the code as whether it's secure or not. Our normal 3 slides. So in chapter 12, secure applications, we look at how to identify and categorize application attacks and hopefully develop and deploy secure applications. There are 2 modules here, again, module A and B. In module A, looking at just application attacks, hopefully you can categorize them in terms of vulnerability and the techniques for the attack, and then understand the general injection attack and then what we call client-side web attacks. So when you hear the word application vulnerability, basically we're talking about how adversaries exploit web applications, the browsers, the database, scripting languages, and in this case, it doesn't really matter your network protocol. Some of the common attack strategies, they can be classified as application attacks. But the point is that most of these vulnerabilities or weaknesses based on the applications and the protocols that are maybe too trusting of the input that the applications receive, especially if you think you are already authenticated or the service is authenticated. So they somewhat trust you unwittingly. So some of the exploits of the application includes privilege escalation, like going from a regular user to an admin, directory traversal, going from maybe the word directory for those of you, maybe one folder to another folder, and arbitrary code execution, and then also resource exhaustion. I'm going to show you the website for OWASP top 10 in a minute. Right now, usually we have the 2017, the 2021, and now for 2025. As of this, I'm recording this video November 2025. There's already a new list of the top 10, but there's also top 10 API, but we'll try and look at them in a minute. But normally it talks about injection attacks, broken authentication, misconfiguration, cross-site scripting. And the whole idea is to look at the ones, maybe 2017, 2021, and see which ones continue to be in the top 10. That means that's something that you need to be aware of or practice against, especially if you're going to be a coder or somebody managing a team of coders. All right, so for input validation, you can have issues like header manipulation, memory manipulation, but you have this broad term called injection, which is you send like some specially formulated inputs that you process within the web application or host machine. So I'm injecting it. For the OWASP top 10, again, you always see, I just went back so you can see that sometimes SQL injection or injection in general are always going to be listed as one of the problems in there. And then again, I said API. So now the OWASP project, which is Open Web Application Security Project, they also have the one for APIs. So APIs are generally a way for applications, right, to communicate between themselves. Like if you have if you have an app, for example, and inside the app maybe displays time, so that your app has to call that widget for the time, so they are communicating between themselves. So most of the API risk you talk about, you hear about web APIs and other network-based interface. For the input, how do we, going back again for input validation, let me go back, right? I can inject this in the memory or whatever I'm trying to do so that I can manipulate what is happening. All right. Part of what I'm trying to do, for example, with the memory vulnerabilities, the memory, you have what's called buffer overflow, like integer overflow, dereferencing, memory leak. When you get integer overflow, you should know what an integer is by now, right? As opposed to a decimal, right? And then the buffer, the memory spot. But these are different ways for applications to be attacked or vulnerabilities in the actual applications. So you also have what I call race conditions. So programs, they have call it jobs to do or tasks to do, and they usually have to do it in a particular order, like a dependency. If you don't necessarily do one immediately after the other, but you have to do them, right? So you have this concept of time of check to time of use. When did I check that issue so that compliance, if I can use it? So when you use here the word race condition, basically it just explained to you, just think about the race I'm running, right? Most computers, they have like multiple programs that they're running simultaneously and at temp speed, like if you do your task manager, you see like apps that are running. So you're just telling you that race conditions, most of the time, they might just be like bugs that generate errors or corrupt data, which is basically is bad. But if I'm trying to run many together, I just need to be aware of the race conditions that can they introduce vulnerabilities in the app. So also for malicious updates. So if you have an update that is claiming to fix like security vulnerabilities or add new features, but you don't realize that there's actually a backdoor, right? Or maybe a spyware or that kind of malware that is introduced into your system. He's just telling you that it's always easier to introduce, it's easier to protect against alterations by a third party if you use applications with signed installers and you make sure that you get them directly from the developer's website. And also, if you secure your supply chain by verifying that software vendors use a secure development process. It makes the news all the time that you install an app, whether it be SolarWinds, the network monitoring tools, or the recent one with CrowdStrike. You trust in it because it's coming from a known vendor, but just understand that there could be built-in bugs or security issues in there. If there's an update, and in that update, the adversary has installed spyware, or the developer didn't test the code properly, so you now deploy the new one only to introduce problems in your system. So there is a lab that we have about exploiting an overflow vulnerability. Ask me if you have any issues with that. And then, sorry, let me go back to the previous slide. And also there's another one for time of check and time of use vulnerability. So a very popular one that was in OWASP Top 10 2017 and also 2021 is SQL injection. This is one of the most common and dangerous attacks for web applications. So secured query language, obviously. So structured query language, excuse me. So it's a standard query that's generated by some mix of like page scripts and client input, all in like a control manner. So if a standard one would be like 1 equals 1, see on here on this slide, that's always going to be true. So you're now going to inadvertently expose the database to being retrieved. The techniques would be unfiltered escape characters, improper input types, stacked queries, blind injection, signature evasion. But the point is that if you have secured coding and you test this properly, you should be able to avoid this, right? If you're using proper coding practices. So how do we defend against SQL injection? Basically what I'm trying to say. Sanitize your input by filtering or substituting like the dangerous characters, validate the input, making sure that all the data is in the expected format before submitting it as a query, like it should be numbers instead of characters or vice versa. Restrict the privileges both for the users and the application itself, so that if there's a problem with the injection, you reduce the impact of it. And of course, always try to minimize end user error messages because you think you're doing a great job by telling the user this is the error, but an attacker sees that error message and studies it and sees the vulnerability and uses it to infect your system. The other injection attacks, NoSQL, LDAP, lightweight directory, command injection, and DLL. Propose the exam, try to understand what a typical SQL injection looks like, a command, and how do you protect against it, right? So here now we want to talk about directory traversal. If I have a securely configured web server, you should not be able to request files outside of the file hierarchy, the folder hierarchy structure, sorry, right? So you should have host system permissions limited to files it needs to do its job. So if I can get somewhere outside of the hierarchy, then there's a problem in there, right? Again, configuration errors allows people to add file operators into the URL or some other way of doing injection inquiry. See this one like a slash goes to the parent directory. So if I don't guard against that, somebody can traverse into the place it's not supposed to do. There's if you're going to test web vulnerability, there's something called DVWA, damn very well, the damn vulnerable web application. So it is a good, you can put it on your, like install it on your virtual machine, and you can use the test vulnerability. So there's an exercise in there, but you can also get online yourself. All right, so client-side attacks, that's attacking me here on my own host machine, as you see in this diagram, as opposed to attacking on the network, right? So application vulnerabilities, browsers, add-ons, malicious add-on, cookies, attachment. This is like ways that I can do on the client side. So remember phishing from before, and then farming is the one that has to do with the website, right? That's all this picture is showing you on the right side to do that. One of the popular one is the cross-site scripting, XSLs. So basically, maybe I want to access the site's tracking cookies to steal user information. We always say cookies are not really dangerous by themselves. It's just if an adversary gets a hold of the cookie, the information inside, and obviously they can use it in an unintended way. If I steal session cookies, it allows me to do a session hijacking, self-explanatory, right? If I access resources that already you have a legitimate permission on the site to use, like a webcam, microphone, but me, I'm able to take advantage of that, right? So that's a way of, it's a cross-site scripting. I want to distinguish it from the next one. I seem to confuse a lot of students. But just for now, just know that there are three major types: stored or persistent. It says in this one, the attacker somehow uploads the scripts to the server. Reflected or non-persistent one, you place the script into a server request that will cause it to be displayed word for word on a web page. And then you have the DOM one, which is either stored or reflected. But the one that confuses people is the CSRF or XSRF, which is the cross-site request forgery. So you might see it referred to with a C or X as the first letter. So the cross-site scripting exploits the user's trust of the website. So I've trusted the website, and because I trust the website, I now become susceptible or a victim of that website. Whereas the cross-site request forgery exploits the site's trust of the user and then does things that normally would not have done. Most of the cross-site request forgery tend to be more on the client side, like on my side, right? Because the sites already trust me. But you do have some that has to do with the server side. You might see the SSRF. In that case, it's exploiting the vulnerabilities in the servers, especially if you have communication between what's called REST API. You just understand cross-site exploits the user's trust of the site, whereas the cross-site request forgery exploits the site's trust of the user. So like maybe with that, with the like in the server-side request forgery, I'm spending time here so I can explain it. I have a target URL, right, like a website called by this server. So it might include like pages, other files. and other web services. So with this one, I can now modify the search. Usually it's good to see an example, like a bank account, give an example, how people, if I plant malicious code on a comment page in a website that people visit, the question is now, the user visits that, and by going to that comment, clicks to read the comment, is now going to execute code on his side, right? That is on him as a client side. That is typical XSS, and I'll show you the example for the cross-site request forgery in a minute in the review question, right? The best way is to just do a lot of test questions or read a lot of cases and then distinguish. But if you keep in mind who is being exploited, where is the trust base? Is it the user trusting the site or the site trusting the user? Then you will know the difference between the XSS and XRSF. There is a lab in here again also for the XSS attack in that vulnerable website that you might want to do. All right, quickly, a few review questions on application attacks. An attack on your web application began with a long string of numbers sent to a field that's only supposed to hold a 4-digit variables. So you know if he has a 4-digit variable, then he's going to have a limited capacity, right? So you're thinking the memory, buffer. So what kind of attack was it? Choose the best response. So in this one, because I'm talking about limit in the size of the input field, it's going to be buffer overflow. What application attacks directly target database program sitting behind web servers? Select all that applies. So in this one, you got more than one option. But break it down and think about it. I know it's a database attack. So most of the time, if it's structured query language, I'm going to be thinking SQL injection. That one is a little easier to get out of here, right? But how do I get to the database when if it's behind the server? That's a good way to pass this question. So that's what I'm going to think about XML injection. They are both injection attacks, right? But now I had one of the students debate one of this with me, but just pass the question and then figure it out. I mean, I said divide up the questions. Okay, look at this one, for example. What kind of attack targets back-end components in an enterprise network by exploiting their trust in a public-facing web server? Choose the best response. So I already told you that in this case the back-end component, right, in the network, they trust a public-facing server. So that is the site's trust of the user, right? And because it's now on the enterprise network, I'm going to be thinking about, and we didn't talk about stack smashing, and I'm not talking about going from one outside of the folder hierarchy, right? So it's easy to eliminate A and C. So now you're now left with B and D. Because I am talking about server side, then it becomes SSRF. That's one good way to. You're going to be more confused if I put XSS there, right? All right. What XSS cross-site scripting techniques don't require the attacker to store data on the target server? So, and it says select all that apply. Sorry, apply. So this way, you're going to have to go back to my definition, right? For one thing, it's reflective because it's not persistent, so that means it's A and C. What application vulnerabilities can be exploited by providing a series of standard data inputs with a specific sequence? Think about it. I'm thinking about sequence and timing. Sequence and timing, right? So you're already thinking about, am I running? Which is race conditions, right? So it's not buffer overflow. I'm not talking about the limited space. And I didn't inject code, right? So that would be C. All right, modules B, basically securing applications, secure development process, secure coding methods, and then how do we test and harden applications. I should also say that the American Software Quality Assurance Board and the International Software Testing Qualification Board, ISTQB. I know it's a lot of words, okay? They have a certification for software tester, so I encourage that you do that. I'm a certified software tester, but also they have another advanced one for certified AI tester, which you use AI to test applications, also test AI systems. And I have that. So it's good to have those two if you're going to do software testing or AI testing. All right, so here we're going to look at these three bullet points quickly. But SDLC, something you have to think is system development lifecycle, but here it is software development lifecycle. And just 5 simple stages here, from initiation to development to implementation to operation and maintenance, and of course disposal. Right? Think about it. Some of this might map into if you know about project management. How does this relate? These are the 5 steps, and you need to know the 5 part of the cycle. For software assurance, when you're buying a software from a vendor, examine their security features and their design process. Make sure that they are engaged in secure coding principles. So you don't just buy any software out there. Right? So I'm not saying only go with established companies, but just make sure you examine their process for developing their code. These are the 2 main software development models. The other ones, but waterfall is our classic project management. It goes all the way from requirements analysis, design, development, testing, all the way to maintenance. Then you have this agile methodology that is very popular now. You have to say the Scrum or Scrum Master Agile. So it's still the same, but it's more iterative. You will hear them distinguish the 2 processes, saying Agile is more interested in developing code quickly to the client, as opposed to fulfilling requirements, right? So that's, but now we normally have devs, ops, and you have DevOps. Now you have DevSecOps or SecDevOps. It just means we combine all 3 together. Security is now built in together. And this helps as we're producing. It's believed that this makes it faster to get the product into production. You will see stuff like continuous improvement, continuous development. So just know that SecDevOps just means we're combining DevOps and SecOps together. Right, so how do we apply application security principles? OWASP gives us some recommendation. Defense in depth, avoid security by obscurity, which means people that don't know what I'm doing. So no, let people know, because it's believed that open design have better tested flaws, reducing overall risk. Keep your security approaches simple. Design application by being distrustful. Like, I call it zero trust, right? But here it's talking about external design, even within the same information system. Just apply zero trust and configure your application securely by default. And always log all security events that may reveal an intrusion or security failure, and make sure that there are clear procedures to monitor logs and respond to incidents. These are some of the recommendations from OWASP. You can see it on their website also. But this is secure development. Secure coding methods, from least privilege, input validation, input sanitization, using cryptography, API, code commentary, very important. Data exposure, database protection, memory management, and even error and exception handling. These are very, very important. But let's see if we can look at just a few of them in depth. Input validation, validate your queries by filtering for what may cause errors or allow exploit. Like, I'm supposed to get letters, special characters. I'm supposed to get numbers. Instead, I see special characters or symbols. The length is improper. Negative values. If I'm doing payment, that should not be there, right? Some other unexpected codes, such as SQL, JavaScript, XML, that might be mistaken for code by a browser or server-side application. This could be an way for the adversary trying to inject something and then run it on your system. Again, you see client side versus server side. There's a debate, the validation. So for client side, it says uses browser script in the page initially sent by the server, whereas for the server side, the validation uses codes on the web application to validate codes before the rest of the program acts on it. How do we manage our sessions to protect against attacks like session hijacking, the XSS or click jacking? It says use session management solutions that have built-in well-established development framework. Session ID should be long and unpredictable. Session cookies should be placed in a cookie HTTP header. The cookies must be set with attributes to restrict how they can be sent over the network. Provide an easy way for users to log out and completely terminate the sessions and delete all associated cookies or tokens. Also here for ways to prevent the cross-site scripting. So never insert untrusted data except in allowed locations. You see all this one, apply HTML escape, attribute escape, Java escape, CSS escape, URL escape, and of course, use a sanitizing library that is specially designed to parse, right, and clean HTML input. That is why I say, so I started coding in 85. Now I don't do a lot of coding, but you need to be experienced in coding and you need different tier in your code, in your coding practice. So make sure that you don't introduce unnecessary errors, right? For the cross-site request forgery, you need some different protection method. That's what it's telling you here, right? Maybe because it's typically they rely on a malicious link or message that inserts code into the victim's browser, right? So because of that, it will now make you do an unwanted action in a legitimate site, right? You already authenticated onto, right? So you can stop this through other methods, although XSS might not be able to do that. But it just says you can use ways you can circumvent it by having protection. So it's essential to do both at the same time, right? So always have methodologies that guards against XSS and CSRF. For software diversity, you hear the concept. It just takes about maybe I have the same, different instance or versions of the same software against different. So it says so have different profile against attacks. So even if I'm having, look at this example. Natural software diversity is found in any mixed software environment like Windows, Linux, or Nginx, or Apache, right? So as a development strategy, what it does is it relies instead on techniques that make the software more unpredictable from an attacker's perspective. So I believe that if you do that, you're minimizing the impact on developers, administrators, and users. So many times I find that these things could be complicated or expensive to maintain, but again, it addresses space layout randomization, ASAR, right? So just be aware of that. Software diversity is encouraged if you can afford it and if you know what you're doing. All right, there's going to be an exam question on how to test software, how to test applications. I told you at the beginning that the International Software Testing Qualification Board and the American Software Quality Assurance Board, excuse all the long name, they have separate certifications. But on this exam, you're probably going to get one or two questions on that. But this is what you need to know when you're looking at a question on testing software. Is it asking you about testing the code without running it, or is it asking you about running the code as a way of testing it? Once you see the question like that, you can figure out what it's doing. Because static code analysis looks at the source code for potential problems. Then if you talk about security analysis, then it now becomes SAST, right? Dynamic requires you to look at a program that has been compiled and then executed. It is focusing on the security and is now called DAST, D-A-S-T. So that's the easy way to distinguish between static code analysis and dynamic code analysis. Now you can get into more in the other exam where it talks about black box testing, white box testing, all that. But here now, this is what you need to know here. Now, stress testing basically means running the application or the system, obviously, because it also applies to system under a strenuous condition. So you're doing it, you're stressing it so that you can see problems. You're basically intentionally trying to create problems to see how resilient the program is, all right? All right, for development environments, we want to just compare production environment, test environment, development environment. Just telling you that production environment are typically the most visible to outside attack because it's right there for the public, right? For staging environment is a good way to test security controls. Test and especially development environments are a tempting target for an attacker who wants to examine the application functions, right, or to steal or modify source code. Sensitive data like such as PII can be exposed from any of the environment. Now, software testing, or just like AI model testing, you have like the data that you use to test it. You have a testing data and all that, but just keep that in mind. What are you using to test your application? You hear what's called adversarial testing to try and do what the enemy wants to do. But here, just understand that production and environment is what is attacked most of the time, but it doesn't mean that you should not be aware of development environment, right? Code quality, this is self-explanatory. Just make sure you carefully review third-party or reuse contents that you include in your code. If you don't do that, you're going to have a problem because so many third-party libraries have serious unpatched vulnerabilities. To try and use the most recent version. But check where you're getting your code. Again, static analysis is what we talked about previously before, but it could be formal, or it could be lightweight. Before, you used to have what is called a peer-to-peer review of code or over-the-shoulder review, where other people are over your shoulder while you're doing the coding. But static analysis technique might be data flow analysis, control flow graphs, taint analysis, lexical analysis. Just think about it. Static means stationary. I'm not running anything. So that will help you to know whether we're talking about static or dynamic, right? So DAST is most important for commercial software or unfamiliar binaries. Some of their methods include using synthetic transactions, not real one. You create the transactions, right, to verify what you expect. Later on, if you take the software one, you hear what is called test oracle problems. But for now, just understand that I have all this, I don't want to call it fake transactions. I create the transactions, I can test it. And then what's called fuzzer to send invalid or randomized input to the application. And of course, run the program with debug modes or enhanced logging enabled. So if you use a debugger to run the software under control condition, it really helps you to get the program, I guess, without the vulnerabilities, but also it could be a long, tedious process, depending on your patience. I remember in days of coding, I used to be very annoyed when I'm like running the program, looking for an error, and then somebody just comes and says, oh, that's the error, right? That's why sometimes you just have to step back. All right, sandboxing. A very good thing to do with like virtual machines. We've got malware sandboxing platforms like Cuckoo Sandbox or Joe Sandbox. These are developed specifically for malware identification. But basically, you can test any kind of software by running a virtual machine in your virtualized platform of choice. I use Oracle VirtualBox a lot because it's free. Just know what you're doing. You should disable things like shared folder, and maybe you don't need to be able to go outside of the internet, just to be careful about VM escape. Mobile device app or C-root jails in Linux, limited system resources available. Just be aware of that. Sandbox environment. We talked about this in one of the sections. Right? How do we harden applications? You should harden the host and the network, configure the application, test the application before you deploy it to production, and maintain the deployed application security over time. Change management also applies to software. You request the change, the control of the change, version control, and release, and of course, configuration management. Version control is very important so that you can roll back to a previous version if the one that is in production or you're running currently has a problem, you can go back. Whether you're using any kind of Git feature like GitHub or Google has their own. All right, examine application vulnerabilities. That's a very good lab. I've done those labs. I find them very, very good. Sometimes if I teach these courses so many times, and once in a while I have to remind myself, go do the lab again so you can remember. Especially every semester I've been teaching before the university. I was teaching at the community colleges for years, but I've been teaching this course for almost 7 years at the university. So I have to remind myself. And of course, I've had my Security Plus for, is it 9 years now? So some of the exam contents have changed. So with me, I have the CE, so I have to stay current, and I'm a member of the Instructor network, and we always go to train the trainer. All right, let's look at some review question. You want to test an application to make sure it doesn't behave insecurely when it receives non-standard input. What techniques should you use? Choose the best response. Think about it. It receives non-standard input. Fuzzing. Okay. All right. What kind of attack do synchronizer tokens help you prevent? Check the best response. Synchronizer tokens, right? That's for cross-site request forgery. All right. You are researching a recent XSS attack against a web application. The developer showed you the JavaScript code used to sanitize and validate input in the browser. So it says, even if you're not a coder, it seems like it would have prevented the attack. What is the most likely reason the web application was vulnerable? Choose the best response. This one requires you just focus. Okay, we already know it's XSS, right? So, oops, sorry. The answer is A, client-side validation can be easily bypassed. All right, so let's see which one is easy. Is there an injection attack to bypass the input validation so you can eliminate D easier? Input validation doesn't reliably protect against XSS attack. Eliminate that. So now you're stuck to deciding whether it's A or C. So the question is, was it on my side or on the server side? All right. You are viewing a web application. Which of these features are security warning signs? Select all and apply. When you're reading a question like this, just have like a gut feeling about you're taking Security Plus. So maybe you already had A plus and Net plus, or maybe if your contract required that you go back and get this. But when you should have some experience in looking at this question. But if you don't, have a gut feeling. Input errors are logged and clearly displayed to the users in full detail. That's like, man, I'm telling them what they did wrong. That means I'm basically telling them how to fix their attack to be better. The web server and database software are separate physical servers, but similarly secured. So they are segmented. Is that a good security measure? Input validation is performed more rigorously, on the client side than on the server side. The HTTP only flag is set on sessions cookies. Secret cookies are used to prevent cross-site request forgery. So we already know that A, maybe what I was reading, is bad warning, right? Don't give too much details to the person that is trying to brute force your network or do the wrong thing. And then you should perform input validation rigorously on both sides, please. Secret cookies are used to prevent the XI. That could be a warning, all right? What security technique is the most useful for preventing session hijacking? Think about it, right? Man in the middle. So I am here between Bob and Alice, and maybe Bob goes on the internet, and in that session I want to hijack, right? By maybe getting this cookie. But what about, how do I have to, what would I have to do to see the cookies, right? So it's not the API hardening, because it's not talking about me calling me another program. It's not about sanitizing my input. It's not about testing my malware. So if I use process elimination, I know that secure cookies is going to be my answer. All right, so you should know how to identify common application exploit attack techniques, such as memory manipulation, SQL injection, client-side web attack, secure applications through the entire development life cycle using a sound development module. So the OSI top 10, this is the website I suggest that you go and check. Let me just tell you what I expect you to look at. Let me stop sharing the screen and I'll take a few minutes and go and show you on the internet quickly, a web browser. That I'll just share my screen, and then from my screen I'll go over to the internet. You see my screen here, and reduce the screen. But if you go to this, let's do this. Eliminate that sharing. But while I'm getting the slide, I want to keep reiterating for you that cross-site scripting, cross-site request forgery, they can be confusing to people. So try and know the distinction between the two of them because you're going to be tested on them. Let's see here. I'll share my screen to any blank. I'm going to say OWASP top 10. And when you go on here for the OWASP project, it's going to tell you that the one for 2025 has been released. It says we need the comments filed by December the 20th, which is 5 days ago. But look, if you click on here to see the candidates, you now say, okay, let's go back. During the release of the OWASP 2025, this website is a bit messy. So it's not giving us, so let's scroll back to, let's get to the API one, right? You can donate to the project. Let's change this to top 10 API. And then you read this, and at your leisure, go through them and you see what it says, like what is an API security. It gives you a broken object level authentication, broken authentication. It goes through the whole thing. So just look at the site. I'm going to now go back to API, top 10 for 2021. OWASP top 10 2021, which would be in the archive library. So I'm going to go to previous one, and it's a PDF, should be a PDF document, but try and read this thing if you're a programmer to understand what it's talking about here. This is, my network's a little slow here, but please go through that. I've shown you how you can navigate that and then look at, let's see if I can just get it from the search here and then comment for you, because you want to see which ones continue to appear every year. And that's something that you should tell you as a developer that you should watch out for. All right? Okay, well, connection is lost there, but check it and good luck on the exam. Send me messages. And when the one for 2025 gets published, we can all discuss it. It gets released every 4 years. Good luck on your exam.